The next layer is called the network layer. Discussing the network layer, we will analyze details of the IP version 4 protocol, and we will say a few words about the IP version 6 too. Both versions of the protocol are responsible for delivering the protocol to the given address. Another protocol operating in the network layer is ICMP, and it is used for diagnostic purposes. Executing a ping command usually results in sending echo packets of the ICMP protocol. Previously, we discussed Ethernet addressing and MAC addressing. IP numbers are called logical addresses due to the fact that they're allocated by administrators or users. The network layer includes routing. Therefore, IP numbers must be allocated in such a way that data will be delivered to both correct hosts and correct networks. An IP number must contain information about the network address and recipient host address. IP version 4 consists of a 32-bit number divided into 4 octets. Octets are separated by dots. This is for users' convenience. Computers treat it as a uniform byte stream. You may ask, which part of the IP is the network address and which is the host address? We'll discuss addressing in greater detail while analyzing the subject of subnetting. For now, you should only remember that each IP address should be associated with a subnet mask. The subnet mask specifies which part of the IP is the host address and which is the network address. The mask is usually given in bits. Usually the bits for the network address are all set to 1. The last principle of the IP version 4 addressing is the network address must precede the host address. In the mask, all number 1s must come before the first 0. In the third layer, IP packets are called datagrams. IP spoofing is as easy as MAC spoofing. There also exists a possibility of a routing table modification attack, to which IP version 6 is especially vulnerable. In the network layer, just as in the second layer, frame headers are not encrypted. IP addresses of both the sender and receiver are sent as plain text. Everyone can read them and even modify them in real time. The biggest vulnerability of the network layer is IP spoofing, that is, impersonating other IP addresses. Attackers use this method to hide their hosts. If the administrator notices in the event logs that someone has scanned his or her system, the IP address of the sender of scanning packets will not always be the one of the attacker. It may be a random address or the address of a computer the attacker previously found in the network. IP is a routable protocol. And the fact that IP datagrams are so easily routable is the reason why protocols become so successful. The IP version 4 protocol has become very popular within just a couple of years, and has completely replaced competing protocols IPX and SPX, which are now totally forgotten. When it comes to routing options, there's been a great deal of change between the 4th and the 6th version of an IP protocol. The IP version 6 protocol configuration is by and large automatic. This means, for instance, that if a network doesn't include the DHCP server, you still don't have to configure the IP version 6 protocol manually. A local address will be provided automatically. And if your router supports IP version 6, global broadcast addresses will also be provided. This means that the computer reacts in real time to the router advertisement. Routers advertise some packets and the system configuration is adjusted accordingly. This mechanism gives rise to two risks. First, it allows attackers to spoof broadcast packets. The attacker can configure IP version 6 addresses in such a way that your computer will treat every other machine as a member of the local network. Usually, the network firewall settings are different for local networks and external networks. And that's how the attacker can very easily change the configuration of a host network firewall. The second risk can now be mitigated thanks to network hardware improvements. But in fact, the vulnerability was a consequence of following the RFC standards. IP version 6 hosts listen and react to packets broadcast by IP version 6 routers. As stated in the RFC, injecting false routes into the network will block hosts. If you resend a spoofed broadcast packet with a false routing path a couple of times, it'll prevent the target computer from communicating with the network. Usually it takes 200 to 500 such packets to completely disable the computer. It'll consume 100% of the processor usage. This means that every computer that supports IP version 6 and all modern operating systems that do that by default can be remotely disabled. Through such an attack, you can disable web servers and servers for cloud services. In a while, we'll show just how easy it is to do that. But first, we'll discuss the second protocol of the network layer. That's ICMP.